Hello everyone, welcome to the part 2 videos of Form 4 Additional Mathematics Chapter 5 Progressions. And in this video, we are going to look at the sum of the first n terms for arithmetic progressions. So before we continue, if there is any errors or any corrections, I will post it in the description below. So let's start. So the sum of the first n terms in this part, we have a formula. So for this formula, the capital letter S with a subscript n here represents the sum of the first n terms. And it is equals to n over 2, and then in brackets 2 times a plus in brackets n minus 1 times d, where a means the first term and d is the common difference. So in this video, we are going to focus on how to use this formula to solve some of the questions. If you're interested in how to derive this formula, you can refer to the textbook. And is the meaning of sum of the first n terms actually? Okay, so we go straight to the examples so that you have a clearer idea on what is the meaning of sum of the first n terms. So we have the first example here. It says, find the sum of the first 10 terms in the arithmetic progressions. So you are given this arithmetic progression, negative 2, 1, 4, and it continues. So we want to find the total. Sum here means we want to find the total of the first 10 terms, meaning that we want to take the first term, negative 2, plus the second term, 1, plus the third term, 4, plus the fourth term, the fifth term, the sixth term, until the 10th term. We want to add all these terms together, which is the value that we are looking for. So in order to find the sum, of course, you can list out all the numbers, all the terms. You can list out all 10 of them and then you total up. But there is a smarter way, which is by using this formula where we can find the sum. S is for the sum of the first 10 terms. Okay, so according to this formula, first we need to find the value of a, d, and n. So the value of a means the first term, which is negative 2. D, the common difference, we take the second term minus the first term, we get 1 minus negative 2, you get 3. And of course, because it's first 10 terms, so n equals to 10. We substitute this into the formula, we get this as 10 means the sum of the first 10 terms. We calculate this, we get the answer 115, meaning that negative 2 plus 1 plus 4 plus the next term should be 7 plus and we add until the 10 terms, the first 10 terms, you will get the total of 115. This time we have 3, 8, 13. Given that this is a arithmetic progression, then we can use this formula to find the sum of the first 10 terms. Okay, so we don't have to list out all the other terms. We just use this formula, find a, d, n, and a is the first term, which is 3. D is 8 minus 3, which is 5. N is 10. Substitute the values inside the formula. Calculate this. You get the answer 255. Meaning that the first 10 terms, when you add up all the terms, you get a total of 255. Before we look at further examples, we come back to this formula again. And you can see that actually 2a here actually means a plus a. A plus a equals to 2a. So you can break this down into a and a. And remember, in the previous video, in the first part of the lesson, we learned that if you want to find the nth term, we use this formula. And you can see that this a plus n minus 1d is actually here, right? A plus n minus 1d. So we can substitute this with tn. And the rest is still the same. We only substitute this part with tn, where tn is the nth term. Like for example, in the example 1, tn will be the 10th term. Okay? Or we can say that this is the last term in the arithmetic progression where we want to find the sum. So Tn, we can also replace this with another symbol, which is L. L stands for last term. Okay, so A is the first term, L is the last term. So actually, this first formula, from here we can derive this or this. For these three, we can use any one of these according to the situation, where Tn here or the L here stands for the value of the last term. If we know the value of the last term, then we can use this. So right now we go to the rest of the examples. Example number 2, in terms of n, find the sum of the first n term for the arithmetic progression. So this time, you're not looking for the value, but you are looking the answer, the solution here in terms of n. Okay, so sum of the first n terms means we are using the formula for sum of the first n terms, where a is -1, d is 2 minus -1, the common difference, which is 3, and n, since we don't know the values of n, we just leave it. Using this formula, we substitute a with -1, we substitute d with 3. Okay, so you get this, and we just simplify this. Okay, so after we simplify, so 2 times -1 you get -2, 3 times n you get 3n, 3 times 1 you get -3. Then you simplify this, -2 minus 3 you get -5 here, 3n is here, and you just multiply this. N over 2 times 3 over n you get 3 over 2 n squared. N over 2 times -5 you get -5 over 2 n. So this is the answer in terms of n. So for this arithmetic progression, we can find the sum of the n terms just by using this newly found formula. Let's say, for example, if I want to find the sum of the first 20 terms, so I just take this n as 20, replace this with 20, I find the final answer. Okay, so example 3 here, find the sum of all the multiples of 11 between 120 and 300. So the first thing you need to know here, the multiples of 11 between 120 and 300 is an arithmetic progression. So we first find the first term, which is the value in between this 120 to 300, and it is the multiple of 11. It is actually 1 to 1, because 1 to 1 is the multiples of 11. 11 times 11 you get 1 to 1. Okay, so starting from 1 to 1, the next terms will be 132, because 1 to 1, since it is the multiples of 11, so 1 to 1 plus 11 you get 132, 132 plus 11 you get 134, plus 11 you get the next term, and so on. If we write this series of numbers down, we'll find that this is actually an arithmetic progression. So if this is an arithmetic progression, when you want to find the sum of the arithmetic progression here, we can use the formula. So if you want to use the formula, we need to find the values of a, which is the first term. So starting here, because this is the first term, and d, of course, since the multiples of 11, 132 minus 1 to 1 will be 11. Common difference 11. But then, what is the value of n? We want to find the value of n, but we don't know how many terms are there, right? Unless we list all the numbers 143, 154, 143, 154, and so on until the last number closest to 300, which is the multiples of 11. Okay, we know that the last term, which is represented by Tn or L here, is 297, because we can do this backwards. We take 300 divided by 11, 299 divided by 11, do it manually, you will find that 297 is the last multiples of 11 in this series. Okay, so if we know this is the last term, we can use this formula where Tn equals to a plus n minus 1 d, and since this is the last term, we replace this with 297. We substitute a into here, we substitute d, then we can find n. Okay, so you see Tn here is 297, a is the first term, which is 1 to 1, d is the common difference 11. If we solve this equation, we can find the value of n, means we know the position of the 297. Which term is this? The number of terms, and also the number of terms in between 120 and 300. So we solve this, we find that this is 17, means that there are 17 terms altogether. Okay, starting from here, 1 to 1, there are 17 terms, which is the multiples of 11 in between here. So since we have a, we have d, we have n is 17, then we can use this formula. So since we know the last term is Tn, which is 297, we already know the values of this, we can use this formula. Remember, there are 3 formulas. This is one of them. Okay, so I can use any one of the 3 to demonstrate how to use this. I choose this formula this time, where n is 17, a is 1 to 1, Tn will be the last term, which is 297. So I substitute the values, calculate, I get 3553. So this question is different than the previous one, because first we need to find the value of n. So if we want to know how many terms are there, we can find the last term, use the last term to help us to find the value of n. Then from there, after we find the value of n, then we can use the formula of sum of the first n terms. So of course, we can choose to use this formula or this formula. It's the same. Okay, you substitute the values inside, you still get the same answer, 3553. Example 4, evaluate the sum of the following series. So given that this is a series, we want to find the sum. The first thing we do, we need to check whether this is an arithmetic progression for each of the terms here. Okay, so first we check, okay, 2 plus 5 equals 7, 7 plus 5 you get 12. Hence, we know that this is an arithmetic progression. Because the common difference, 7 minus 2 is 5, 12 minus 7 is 5, it's the same. If we can identify this is an arithmetic progression, then we can use the formula. This formula can only be used for arithmetic progression. And we find the value of a, the first term, 2. The common difference is 5, 7 minus 2 is 5. And now, again, we don't know how many terms are there in between here unless we list out all of them. If we don't want to list out all the terms, we need to use the last term to help us to identify the value of n. So n, what is the value of n? We find the last term. We use the last term Tn here equals to 147. Again, we use this formula where Tn is 147, A is 2, D is 5. We substitute inside here. We solve this, and you get n equals to 30. So we know that there are 30 terms altogether here. So after we find the value of 30, we can use this formula or any one of these formulas since we know the last term here. Okay. So in this case, I just use this formula. Since n, I already know that is a 30 here. Okay, so 30, A is 2, n is 30, D is 5. Substitute into this, I get the answer 2235. Example 5. The sum of the first 5 terms of an arithmetic progression, so this time we know it's an arithmetic progression, is negative 25. And the sum of the first 7 terms is negative 21. You are now given the values. Find the sum of the first 12 terms. We want to find S12. But before we find S12 using the formula, we need to find the values of A and D from these two information. If you can find A and D, here we know n is 12, so we can find this using the formula. So I just list out the first information here. Sum of the first 5 terms is S5 equals to negative 25. So if I substitute the values here using the formula here, I get this is equals to 5 over 2. N is 5, 5 over 2. A, we don't know yet. N is 5. D, we don't know yet. Simplify this, I get this. I label this as equation number 1 because I know that I have to go through the same thing in using the second information. The sum of the first 7 terms, S7, equals to negative 21. I do the same thing here using N7. A, N7, D. Simplify this, I get this. Label this 2 because I have 2 equations with 2 unknowns. So here I just solve it using the simultaneous linear equation. I take equation number 1, I move this D to the other side, and then I divide all with 5. Okay, so divide all with 5, I get this. I substitute this into equation number 2. I substitute A here with negative 5 minus 2D. Substitute this. After I substitute, I only have D left, so I can solve for D. Okay, simplify here, solve for D, and I get D equals to 2. After I get D equals to 2, I can substitute D back into D here to find A. Okay, so I substitute D to find A. A is negative 9. Now, after I find A and D, I can use this formula to find S12 because we are looking for the first 12 terms. So S12 equals to 12 over 2, where A is negative 9 and D is 2. Solve this, find the values. S12 equals to 24. Example number 6. The sum of the first n terms of the arithmetic progression. Okay, so we know it's arithmetic progression. We're going to find the sum. So we know we need to use the formula. Okay, and this time given that the sum is 144, and instead we need to find how many terms are there. Now the value of n is the number of terms. So again, we use the formula. First thing we find A is 8, D is 10 minus 8, which is 2. We don't know value of n. we know the sum here is 144, hence we use this formula. Sum of n terms is 144. This is 144. A is 8, D is 2. So we have 144 equals to n over 2. Here is 8, here is 2. We solve this, we simplify and solve it. You get this. So you can see that, so when the n multiply with the n here, you get n squared. Okay, so you know that you have a quadratic equation. When you have a quadratic equation, there are a few ways you can solve it. So in this case, we can solve it using factorization. Okay, you get this, factorize, and then you get n minus 9 equals to 0 or n plus 16 equals to 0. So n here equals to 9 or negative 16. But n can only be positive number because it's the number of terms. Hence, we cannot take negative 16 as an answer. We can only take 9. The answer is n equals to 9. If you leave your answer here and you stop, you cannot get the final mark. Okay, you must state what is the final value of 9 if n can only be a positive value. Example 7. The sum of the first 3 terms of an arithmetic progression is 6. So we know S3 is 6. The sum of the first 10 terms is 195. S10 is 195. Now, calculate the sum of the terms from the 4th term until the 10th term. We only want the sum from the 4th T4 until T10. So how are we going to solve this when it involves the sum from the terms which does not start from the first term? Okay, the sum of the terms here, which is from 4th to 10, this does not start from the first term. When this happens, we have different methods. So before that, we try to understand this question again. Okay, so we want to find the sum from 4th to 10. So altogether we have 10 terms here. So I use this to show that this is the sum from the 1st until the 10th term. This is S10. So given that the sum of the first 3 terms, sum of the first 3 means T1 plus T2 plus T3 here. Okay, this 3 is 6. So we know that the sum of the first 3 terms here, S3, is 6. Then we also know that the sum of the first 10 terms, okay, so from T1 here until T10 here is 195. So we know that from term number 1, if we add until term number 10, S10 equals to 195. If you want to find the sum of the terms from the 4th until the 10th here, the one shown with the red line, so it's quite obvious that we take the total here, S10, minus S3. Okay, so to find this, we take S10 minus S3. Okay, this minus this, which is equals to the value of the sum from the 4th term until the 10th term. S10 given 195, S3 given 6, 195 minus 6, 189. We try a similar question. Now, given that Sn equals to 2n squared minus 5n, find first term A, common difference D, the 10th term T10, and also the sum of the 5th term to the 11th term. This one is similar to example 7, but we have to find these values first. Okay, the first term is A. Notice that the sum of the first term is also equals to A, because A equals the first term. So when you sum up the first term only, actually it means the same thing. Okay, this is important. Yeah, A equals to S1 or T1. So if we know n here is 1, we just substitute n here with 1, n here with 1. Okay, so you get 2, 1 squared minus 5 times 1. Calculate the values, you get negative 3. So we find A equals to negative 3. Now we go to the next part, find the common difference. Okay, so given this, we find the common difference. Previously, we learned that common difference equals to the second term minus the first term. So for now, we only know the value of the first term from question A. We don't know the value of T2, the second term. So we need to use this to help us to find the second term. So actually, T2 equals to the sum of the first 2 terms minus the sum of the first term. How do I get this? If you don't understand this, I'll show you how. So let's say if we have T1 plus T2. The T1 here is represented by S1 because the sum of the first term is T1 itself or A. And T1 plus T2, this 2 is the sum of the first 2 terms, first and second. The sum of the first 2 terms is denoted by S2. So if we want to find T2, this value here, we take S2, the total, minus S1. S1 equals to T. So S2 minus S1, you get the value of T2. Okay, so in short, T2 equals to S2 minus S1. So we substitute S2 by using this formula, 2 times 2 squared minus 5 times 2. Okay, 2 times 2 squared minus 5 times 2. Minus here, S1, we get the value of S1 from question A, which is -3. We find the values of T2. Now we substitute back into the first equation here to find D. Okay, so D equals to 1 minus -3, which is 4. So from here, you need to note that Tn equals to Sn minus Sn minus 1. In this case, T2 equals to S2 minus S2 minus 1 is 1, which is this. Okay, so you can always find the nth term by taking the sum of the first n terms minus the sum of the first n minus 1 terms. Now we go to the next part, the 10th term. Okay, so this 10th term, if we only want to find the value of one term, which is the 10th, we use this, the one that I just shown you, where n here is this 10. T10 equals to S10 minus S9. So 10 here, we just replace this n with 10. 2 times 10 squared minus 5 times 10. 9 is 2 times 9 squared minus 5 times 9. So we just substitute the values here. We find the 10th term, one value, which is this, which is 33. Now for the last one, we find the sum of the 5th term to the 11th term. So this is similar to the previous example. So if you want to find the sum of the 5th term until 11th term, which is shown here, okay, so we can use this, again, I use this illustration to show you. Now we take from T1 until T11, this is the sum of the first 11th. But we only want from the 5th until the 11th. We only want the values from here added until the 11th term. We don't want this. If you want to get rid of this, we first find the total, which is S11. We minus the first 4 terms, the sum of the first 4 terms here. So S11 minus this part, which is S4, because it's the first 4 terms. So we find S11 minus S4 to get this, S11 minus S4. Okay, so S11 minus S4, we substitute into the values here with 11, and here we substitute with 4. We find the values, we calculate it, we get this, which is 175. We go to the last example. A graduate is required to pay his education loan of 3,960 in 24 monthly installments, with the first installment being 50 ringgit. Subsequent installments are increased by 10 each month. What is the amount of the last installment? So you have the first month you start with 50 ringgit, and subsequent for the next following month, every month the installment increased by 10 ringgit. Means you add 10 to the following month, add 10 more to the next month. So this is actually an arithmetic progression with A 50, the first term, and D, since every month the difference is 10, so D is 10. So we want to find the installment of the last installment, the last month. And there are altogether 24 installments, means N is 24, because we want to find the last installment. Yeah, so N is 24, and want to find the value of the last installment, means we are looking for T24. So if you want to find T24, we use this formula to find the value of the one term. T24 equals to 50 plus 24 minus 1 times 10. So you substitute in the values, we get 280. Just to be sure, you can find the sum using the formula, sum of 24 using the A and the D, and you see if you get 3,960 exactly. So this is the end of this video. I'll see you in the next video. Thank you everyone.